today our topic is Spectre R and Tiffany. Firstly is the introduction. Spectre R is a Russian scientific satellite. It's a 10-meter radio telescope on board. This telescope was launched on July, and it is 2011, and stopped responding to the ground telescope on January 11th of 2019. One of the instruments is called the Radio Astronomy Program. We can learn from picture is that this spectre, the area of the spectre is very big. It means it can absorb the more electronic waves than the other telescope. See, it's very big. And secondly is the location. It was built in the astron space. It launched into the Earth's orbit on 2011 April. The height of its orbit is about 70 times higher and 20 times lower than the Hubble Space Telescope. This telescope is moving a moon-pictured orbit, which is caused by the gravitation force between the moon and the sun. We can see from the picture, and we can learn from picture that it's the orbit of it in the universe, and we can know that it go around the Earth.
Okay. Next, I will start my next topic. Hello everyone, my name is Brown. My next topic is about the electromagnetic spectrum of the spectre R. Yeah, spectre R can communicate with different bands of radio waves, which operating at 18 centimeters, 36 centimeters, and 92 centimeters, which means that it can communicate or send different radio waves to radio telescope, ground station. It can travel into the atmosphere of the Earth without any obstacles. Of course, it can travel into the universe freely, without any restrictions. The third one is it can send ultraviolet light, which can communicate with the ground telescope. Yeah, when the spectre R receives the ultraviolet light, it can send this light to the ground telescope station, and when the ground telescope station receives this light, it can receive back to the universe telescope of the spectre R in order to communicate to tell about the situation of the universe. This is a picture of the ultraviolet light. As we can see that the sun spreads its light into the sea, and the sea evaporates up. This is the design of the spectre R. It consists of a parabolic reflector and a science payload within two containers, which means a scientific payload is that how many cargoes or how many products can telescope or spacecraft in order to launch to the universe. The instrumentation and the navigating services. Navigating services is like a standard model U, which can give directions to the spectre R in order to travel on the universe. It has a focal length to diameter ratio of 0.3 plus or minus 0.5 millimeters. This is 0.5 millimeters the accuracy, which means it is errors. In order to send this telescope, the mass must be between 2,500 and 3,600 kilograms. This is the most efficient mass intervals for the telescope in order to send it to the universe. This is a picture of that.
Hi, I'm Lance, and I will talk about the justification and the conclusion for the spectre R. First, let's talk about justification. There are three major justifications for spectre R. The first is noise correction. Consider of the high level and the low level generators. There are two kinds of generators, and for the high level one, it can got 1/2 of the system for the temperatures, and for the low level generator, it's just a few percentage of the temperature. All of these number of the noise collaboration events can be preserved into spacecraft times programmed for future observations. And the second justification is from the radio telescopes. As we all know that the speaker is not only observe the universe, it can also check the Earth about like Australia, USA, and Russia. It provides the most clear and the higher sensitivity of the observations. Even usually it is the picture of speaker for more than 1,000 times clearly than the Hubble telescope. And for the data collection, speaker is a very large telescope, and it gives it a very good data collection reactions, and it including the coordinate and the angular displacement. This data from the data acquisition systems. The number of the digital input channel is 8 or 16, and the data rate is 128 Mbps. It can also record data from every single element. And for conclusion, the speaker. It's launched in Russia. The orbit is located in Russia, USA, and Australia. It's stimulating the observation of the cosmic radio sources, and especially for angular displacement. The large collaboration on the track and did lots of research in the celestial bodies with high ultra-angular resolutions. The picture from the speaker is 1,000 times clearer than Hubble telescope. This is our reference list. Thank you for watching. This is